Now, quadratic equations. Quadratic equations are equations having degree 2. Now, we here consider quadratic equations with one variable x. You know the general form of the quadratic equation with one variable, which is ax squared plus bx plus c equal to 0 with a, b, c are constants. And also we know this quadratic equation has two roots, two solutions, and these two roots are given by minus b plus or minus root of b square minus 4ac whole divided by 2a. So this will give us the two roots of the quadratic equation. And now there are three cases. One, the discriminant b squared minus 4ac, this b squared minus 4ac greater than 0, this b squared minus 4ac equal to 0, and b squared minus 4ac less than 0. If b squared minus 4ac greater than 0, then you will get two values for b squared minus 4ac, root of b squared minus 4ac plus or minus two values we will get, and those two values are real values, and therefore the equation will have two real roots. And if b squared minus 4ac equal to 0, then we will be having two equal roots which are minus b by 2a, two equal roots for the quadratic equation. And the third case is when b squared minus 4ac, the discriminant is less than 0. So less than 0 means it is negative, and the root of a negative number, and we know root of a negative number is a complex number, imaginary number. And we discussed this situation here, the solution or the roots of quadratic equation, which are complex roots. And now we know the two roots are given by this minus b by 2a plus or minus root of b squared minus 4ac by 2a, dividing these two terms with 2a. So these two will this minus b by 2a plus root of b squared minus 4ac by 2a, and minus b by 2a minus root of b squared minus 4ac by 2a will give us the two roots. And now consider the case when this b squared minus 4ac less than 0. If b squared minus 4ac less than 0, then this numerator will be a multiple of root of minus 1, which is I, and therefore this can be written as this term as x plus or minus the root of minus 1, which is I, and into some other expression, the remaining part, which is this iy. So the roots will be in the form x plus or minus iy, which are complex roots, complex numbers. And this is the case we consider here. So we can have one or two examples of quadratic equations having complex roots. So first consider this equation, say x squared plus 3 equal to 0. X squared plus 3 equal to 0. This is a quadratic equation in which the term involving x is missing. That means this bx term is missing, that is b equal to 0. So this is a quadratic equation, and we can solve this easily without using this formula. That is, this x squared plus 3 equal to 0 means x squared equal to minus 3, x equal to plus or minus root of minus 3, which is equal to plus or minus 3i, plus or minus root 3i. So plus root 3i and minus root 3i are the roots of this quadratic equation. And now we can consider another one. So consider this equation, say 2x squared plus x plus 1 equal to 0. Then the roots are given by minus b minus 1 plus or minus root of b squared 1 squared minus 4 into a into c, 4 into 2 into 1 which is 4 into 2 which is minus 8 divided by 2 into 2 which is equal to 4. Or this is equal to minus 1, then plus or minus root of 1 minus 8, 1 minus 8 is minus 7. So root of 7i divided by 4. That is, this is equal to minus 1 by 4 plus or minus root of 7 by 4i. So these are the roots of this quadratic equation. Thus we can have solutions for quadratic equation. The complex roots are solutions of the quadratic equation. Okay.